from CSE department, grants a room to respected session expert and various faculty for affiliated institute. In the third session of day 2 FDP, we have Dr. Rajiv Mishra sir as session expert to deliver his expert knowledge in the data management field. He is working as an associate professor in IIT Patna and having more than 15 years of experience. His expertise area are big data computing, blockchain mobile computing, ad hoc network and sensor network. He is fellow of IETE, senior member of IEEE, undertaking various national and international projects. Sir, I am again welcoming you on behalf of RRIMT. Now, over to you, sir.
Okay, thank you so much. Am I audible?
Yes, sir. Yes, sir.
Yeah, you are audible, sir.
Okay. Good afternoon, Dr. SP Tripathi, for inviting me.
I just like to 2 minutes. Sir, Mr. is a very good friend of mine, and he's a very good orator also. And I have listened his talk many times, and whenever I listen his talk, I feel very delighted. I'm also very grateful to him because a single call, yet I request Raul Bolenge, and today he is in front of us. I hope the people who have not done it can immediately listen from him and draw the conclusion from his talk, go ahead for the PhD in his system. We are friends at 25 years. So nice of him. Thank you very much. Pray to the God that Mr. Mishra, you touched the life. Thank you very much.
Thank you, Dr. Surya Prakash Tripathi ji. So it is my pleasure that you have invited me, and our relationship again get refreshed. Maybe I also pray to the God that in future also we will be having such opportunities to meet each other in this way, because it is a COVID situation where online platform is to be used, where the travel is to be minimized. So with this, let us start my presentation. So I will share my slides first.
हमसे डेली ना पूछा करिए, जो डिसाइड हो जाए हमने तो एक बार वही कर दिया.
So is it visible to you all, the slides?
Yes, sir. Yes, visible.
Okay, thank you for the confirmation.
Thanks.
So today, in this particular session, I will be talking about the big data analytics. So in this particular talk, I will give you first from the higher level what is big data analytics. Then slowly we go inside the big data technologies, what is big data, all that things we have to. So this particular presentation is from top-down approach. And I am not going to go in more detail of research, because that will be advanced level on this. So I have removed those kind of slides. So if anyone is interested, he can pose question, or he can approach me at a later point of time, at any point of time. So my email ID is given here in this slide. So you can use this email ID for communicating with me at a later stage. So myself, Rajiv Mishra, I work in computer science department at IIT Patna, and I have my PhD students are already 4 PhD students are joined different institutes. One is in IIT BHU, assistant professor. The other student is in IIT Jodhpur. He is also assistant professor. And another student, he is working in MNIT, Allahabad, as assistant professors. And 4 more PhD students are working with me at this moment. And 2 new part-time PhD students they have joined. One is working in UP Technical Government College, that is Ambedkar Nagar. And another also is doing part-time PhD. He is He's also working in Rajarshi Open University in Allahabad. So that was my this thing details. And I am interested in cloud computing. I have published a book uh, in cloud and distributed computing by Wiley. And so let us start with the big data analytics discussion. So let's see the evolution of the technology and why we are talking, because this is linked to the growth of evolution of the big data, and this growth of technology has enabled this concept of a big data. So you can see that earlier you were having telephones, which was wired, and nowadays you have turned into the mobile phone. And mobile phone is not only just voice communication, all kind of communication using data. A lot of sensors are there in your mobile phone. That particular technology is from phone to the mobile phone journey has changed a lot of things. And now your mobile phone, that means every person is able to generate a lot of data out of their smartphone. Now, another development has happened is in terms of the desktops. So earlier desktops in floppy drive, and you have the means all these devices which were called external devices used to store the data. Now this entire technology is changed. Now data is so huge that you cannot store in a floppy drive or a hard disk drive. You require the cloud to be stored. So the data is humongous. So the huge amount of data is required to be stored in the cloud. Further on, there is another development. So this development is called self-driving car, which is coming up. So self-driving car, just like in the mobile phone, the car is having a lot of data, required a lot of data to move the car forward without the driver. So obviously, this kind of devices, which are now changing as well as the technology evolving, is highly dependent upon the data. Okay, not only they generate the data, they consume the data also. So if the data is so huge, so big, and comes with the variety, all the things will now together will change the definition of the data. So please mute your mics. Please mute your mics. So everyone should mute your mics.
Sure, sir.
Okay, so this is called the evolution of the technology. So evolution of the technology is enabling to generate a lot of data. And a lot of data means a huge volume amount of data is which you cannot store using traditional means of your computer. And you cannot compute and process using traditional means of computation. And therefore, this evolution of technology is going to give you a new way of defining the data. It's not the data which was there earlier. Now the next part over here is that Internet of Things. Not only this technology evolution which we have seen in the previous slide, but now also you have to see that Internet of Things. That means everything is having now the internet connection. And a lot of sensors are there inside everything. So these sensors are called Internet of Things is able to generate a lot of data through the internet, over the internet. And this is, you can see that you can name anything which is basically is embedded with the sensors and connected with the internet, and it is able to generate a lot of data. And so whether it is whether it is the gas pump, or it is a wind turbine, or anything, whatever is parking meter, spotlight, smart meter, and so on, vehicles. Now, another source which is generating the huge amount of data, which people is responsible to generate a lot of data, is the social media. So the people are very fond of social media, whether it is Facebook or it is a Twitter or writing mails or Instagram, uploading pics in the Instagram or uploading videos continuously on the YouTube. So all things are generating a lot of data, and this is called social media. So social media is also becoming rich source of data generation and consuming this lot of data. And the other factors then we have seen, which has been responsible for generating the data, huge amount of data are various other. For example, if you say Amazon or Flipkart, all these are online retail shop, which was not there earlier. Nowadays, they keep the information about the data and about the products. And using this amount of information, they are able to map the preferences. They mind the preferences of the particular person. So whenever using recommendations, when they are going to means visit that the retail sites next time, your recommendations are being given. Similarly, if you are doing online transactions and doing banking, that also the data of a customer is being analyzed to check whether is there any means any security threat is there or not, means a person is genuine who is making all the transactions. So those kind of checks and balances, if you are doing banking, will safeguard the data. Not only allows data generated by a person will check the pattern whether he is the authorized person or authenticated person or not. Similarly, media and entertainment is also quite changing. For example, if you are watching a Netflix movie, so you from users' preferences, it will give you the recommendation of the movies and so on. So healthcare is also another area in which not only it generates a lot of data. For example, a patient who requires continuous monitoring. So continuous monitoring of a patient generates a lot of data. And not only it generates the data, but also that particular observational data has to be analyzed. And then only any deviation or any treatment is further required. It has to be attended by the doctor here in the healthcare. Education sector, now you can see that today's world is now heavily dependent upon the online platform. So online platform will give this kind of education system. The governance, you can see in today's with the digital world, the governance also, Digital India mission they have created. That means all the ministries and all the government working is turned into the digital form of means by which the government is now able to function. Transportation also, you can see now is a way in which the monetization of the highways are done, so that whenever a car is approaching towards those booths which is required to collect the money, so automatically that money will be taken out from your credit card or wallet using FASTag. And insurance is also a business which requires and consumes this particular data. Now, this data is okay. That means big data which is being generated using all the sources which I have told you is fine. But what is the opportunity? What are you going to do with this kind of data? So you can see in this particular in this slide that at the central place is called big data analytics. That means big data analytics is at the central stage. That means it is responsible for various important decision making in today's world. For example, with the big data in place, if you can do the big data analytics and can figure out how the optimizations can reduce the cost. So using the insight of the big data analytics, you can reduce the cost. The second thing is that for any companies, if you have doing the big data analytics of the different data sources of your company related information sources. So if you can apply for this data for faster and better decision making, then you require something which is called big data analytics. So big data analytics will improve your decision making capabilities in the companies, and companies can move much in a profitable manner. Finally, you have the improved services or the products in the form of big data analytics. That means all the products, whether a customer is buying the product, then we can give you the reviews online. So all the reviews are being analyzed and the product is being improved so that next time the reviews will be taken care of further improvement. So this way, the products get upgraded all the time as per the requirement of the people, as the liking of the people. So this is not only the requirement but also the liking of the, so that customer will stay with the product. He will not churn or he will not change the product. So this is for sustainable business trends. This big data analytics is very much required. Similarly, another sector which is about new next generation of the products is about automated car. So automated self-driving car, as I told you, is a new technology which is coming up. Also, it's dependent upon the big data analytics, and healthcare nowadays also becomes a big data analytics. So big data analytics, you can see that is the central stage, and it is giving you much more opportunities to sustain your businesses and your processes and systems in this manner. So now the question is, what is the biggest challenge in the big data? So is it the volume? That means the data is so big that you cannot store? No, it is not the challenge for the big data. Because storage is not an issue here in the big data. What is the major issue is about the variety of data which is being created, whether it is the video, or it is in the image, or it is in the text, or it is the sensor data. So all varieties are there. So these kind of varieties will get a lot of complexity, and that becomes the challenge for the big data. Now, therefore, I can say that the volume is not a problem in the big data. That is, the storage can be manageable. Storage cost is reducing, so storage is manageable. But the only issue is about that complexity, which is about due to the variety types, data types, and their varieties are there. How to handle these kind of complexities is going to be very, very analytics. So if the big data is there, okay, so that means data generated out of different sources. Let us call it that somehow you have the big data. Now the question is, there are two things. This particular big data is so complex due to its variety and other dimensions which is there in the data, that you cannot do anything and you can ignore it. The other way is that you can use this data. That means you can do the analytics in this kind of data and discover the drivers and the insights from it, and improve your systems and gain more profit in the system. So therefore, to do the analytics on the distributed data sources, wide range of distributed data sources, it's not so easy, it's very, very hard. Now, you can see that every organization will collect many different complex sources of the data. And these multiple diverse data sets are often stored in different silos. And these silos innovate the data teams from integrating multiple data sets that could yield actionable insight to create the business business values. So this becomes quite challenging here in the big data that from different multiple data sets, how can you how can you combine together, and then you can do the computation to gain the insights into the data to create the business value. So therefore, you have the lots of information, but you have very few insights how to go about that. So this becomes a bigger challenge. So it's just like you can see here the elephant is depicting the big data, and the blind people are just they are seeing that something is very big, but they are not able to know means how to handle this a big elephant. So that means how the insights are to be gained out of the big data is going to be a crucial thing. So therefore, the integration of multiple of huge amount of data source is that means from multiple diverse data sources is going to be a great challenge. And if you can do this, then you can gain the insight, and you can gain the profits and so on. So therefore, this kind of gaining insight requires to access the big data exploration and exploitation of which diverse data sources that will lead to the empowerment of data scientists, data engineers, and data analytics, everyone. And also it is enabling the cultural transformation that is about the data literacy, data democratization, experimentation, insight discovery, innovation, and business value chain. Now let us see that what are the insight discovery when I say in the big data, which is also classified as in the data science. So insight discovery means that means if you have the big data, then what kind of insights you can gain out of that? You can do a class discovery. That means you can find out the different categories, that is population segments, subsegments of things, objects, events, behaviors in your data, and learn the rules that constrain the different class boundaries. So take this example on the left side. You can see this. You have the some amount of big data, and you have done this clustering. That means you have done the clustering, and clustering will identify different classes. So as you add more data, more classes will appear. So these classes will have the properties that they are alike data together, and this is called a class discovery. So out of that data, big data set, you can do a class discovery, and it will classify the data into different categories, which is called population segment and subsegment and so on. Of various things, that is objects, events, behavior, and so on. So you can apply class discovery as one of the important insight discovery. The another one is called correlation. So correlation is given X. How are you going to predict about Y? This is called correlation. Correlation means correlating two or more means variables together. It's called correlation. So in the example of a correlation is called predictive and descriptive power discovery. So insight, that is also called insight discovery. Using this predictive power, that is called correlation discovery, you can find out the trends. For example, X and Y, there are two variables. Given X, you can find out what will be the Y. So using this correlation, you can find out the trends of that particular liking of the people, trends of the product, patterns, discrepancies in the data level, reveal that the governing principles, causal relation, and so on. So the next insight discovery is called outlier anomaly detection and service discovery, finding the new surprising unexpected inside the data, objects, important insight discovery in most of this big data. Finally, fourth one is going to be very, very important. That is called association discovery or unit discovery. So that means the data sometimes represents the people And these people, they have this relationship, and that can be replicated using the graph and then graph network, and then can perform the analytics. This is done in the using the Google or the World Wide Web pages. So the pages which are and you know that in the Facebook also, the people are having the relationship, and this relationship is to be computed using the network analytics or the graph analytics. So therefore, this way, that is getting the insight. If you represent the data in the form of the graph or the network, that analytics is called graph and network analytics. This is a very good area for the research. So I have skipped these slides because this is going to be a more detailed description which cannot fit into one lecture. So but I am telling you that finding both the mutual and unusual interesting associations using the links and connections across the entities in a domain, you can gain many insights. You can find out various insight discovery. Now let us see what are the different analytics which you see in different business applications. So that means if you apply the big data analytics in the business domain, then there it is called different type of analytics, which gives the business intelligence for business applications. So this is called, first one is called the descriptive analytics, where you will get the questions like what happened. In the sense, if you have the historical data and if you do this insights out of that data, what insights you can identify from the data what has happened. What has gone wrong? That means these kind of questions can be asked from the historical data, that is called descriptive analytics. Then, if you are having a lot of IoT and sensors continuously sending you the data in real time, then from that analytics, which is called diagnostic analytics, you can tell what is happening. That means you can figure out the events in the real time, and this is called diagnostic analytics. So another aspect of the diagnostic analysis analytics is that not only it tells in real time what is happening, but also you can find out why it is happening. For example, if something, for example, if something is some accident or some disaster has happened. So this event, what is happening, you can understand this disaster. Usually, the cause of the disaster, that also you can gain out of this diagnostic analytics. So in the real-time information is being analyzed here in diagnostic analytics. Now another type of analytics is called the predictive analytics. Is going to be very, very powerful analytics that I have. So here, what will happen? That means if you say this is based on the correlation that we have seen in the previous slides. So it will give you a foresight what will happen in the future. That means you will be able to do using predictive analytics predict what will happen. The fourth type of analytics, which is much advanced than predictive analytics, called prescriptive analytics. That is, you can use this prescriptive analytics to find out how to optimize. How can we optimize and what will happen? So that optimizations can be planned using prescriptive analytics, so that you will gain a better planning of the operations and the processes. And finally, the new type of analytics, which is nowadays evolving, is called cognitive analytics. So that means you can see how the data informs the right decisions, the right actions right now. So it's not only unlike descriptive analytics, which will tell you about what has happened in the past. But cognitive analytics will tell all things in future. What event is going to happen, and what is the right direction to move, and so on. So this is the new kind of analytics which is nowadays becoming very popular. Any questions you want to have? Okay, if there is no question, then let us move forward. So therefore, let us see based on these different type of data analytics. So what are the other type of analytics these days becoming popular? We are going to discuss them. So the first one is called streaming data analytics. Here, that is the real-time access to interaction with the discovery from the data. That means the data which is coming in the streams, that is generated in the real time. If you are able to do that analytics on the data which is coming up called streaming data analytics. So out of that streaming data analytics, point of interest, for example, the sensors are giving you the sensor data. Sensor data is the stream of the data which sensors are sending all the time. But out of that, inside that data, if you want to see some pattern, whether the machine is malfunctioning or not, whether any event like disaster has happened or not, whether any fire event has happened or not, all things is done with the help of analytics, which is called streaming data analytics. Now, another type of analytics, another application of streaming data analytics is called to detect the BOI, that is behavior of interest of a person. For example, if you have, if the camera is giving you the data or the sensor is giving you the data, so you are now interested in finding out a particular behavior in this particular scenario. So you want to detect the behavior of interest using streaming data analytics. That means camera keep on sending you the data, and from there you have to find out that behavior of interest. So this kind of analytics is called streaming data analytics. Now, another type of analytics is called team analytics. That is the culture of experimentation, collaboration, data sharing. And next type of analytics is called edge analytics, wherein you want to identify timely information. That is, out of the real-time data which is being collected, you want to figure out what is happening at a particular time. So time, locality in time is that kind of analytics is called edge analytics. Okay, so edge analytics is based on the locality in time aspects. So location analytics, that means in the space, in the geographical space, geospace, you want to find out a particular location. In that location, what is happening, that is of your interest. That is called location analytics. For example, if you want to find out a particular place, for example, in New Delhi, let us say that the Jantar Mantar, what is happening. So this kind of analytics, if you want to do out of the data which you are gathering at a particular point of time, this is called location analytics. And then you have the related entity analytics, that is locality in a data feature space. So what else is like this feature? Okay, so it's like this, that for example, if some accident has happened at a particular place, you want this accident where else a similar event has happened. Okay, so this kind of thing which is called related entity analytics. And then you have another thing which is called agile analytics, that is analytics by design, the iterative building proof of values and so on. So this is another type of analytics. And learning business system analytics is like you are observing a particular business processes, or maybe in the medical domain you are observing a particular patient and you are trying to understand. So that is called learning business system analytics category. So we have seen a lot of different type of analytics and different kind of scenarios in which they are being applied. Now let us understand. We'll take 1 minute break, and then we have to go ahead inside the big data because we have seen about the big data. We will know what big data is, simple definitions, and then we will go into the technology over the next 1.5 hours. Any questions?
No, sir, thank you. We are getting your point completely.
Okay. So, if there is no question, let us move ahead.
Yes, sir, sure.
Okay. So let us see now the definition of big data. What is the big data? So big data is a collection of data sets so large and complex that it becomes difficult to process using traditional relational database management system. So normally, if a small data is there, then you can store and process the relation using relational database management system. But if the data is just called big data, then it cannot fit into the traditional database management system. Hence, if that particular data which cannot be processed using the traditional database management system, then this is one such definition that you can call it as a big data. So now the next question is that what's making so much of data that we have already told that there are different changing technology, IoT, social network, social media, and other related sources, which is also called as ubiquitous computing. And so these are all together is responsible for making so much of data. This is such example that we have already seen, that you have a Twitter, Facebook, YouTube, Google, they're all making so much of huge data, and they are the sources of big data generation. So the sizes are in terabytes. You can see that terabytes is zettabyte, terabyte is a huge size, and how to handle this variety of data of that size, it becomes a real problem. So where is the problem? Is it the storage problem or something else in the big data? So your traditional RDBMS queries is insufficient to get useful information out of the huge volume of data. Okay, so if the volume is big, then that technology which is called RDBMS will fail. It will no longer be effective. Now to search with the traditional tools to find out if a particular topic was trending would take so long that the result will be meaningless by that time it is computed. So you not only you have to do the computation of a huge volume, but you have to do it so fast that it will be useful. So the big data come up with that solution to store this volume of data in the novel means, which your traditional means is not able to do this, and is more accessible, and also come up with the methods so fast that you are able to do this analysis within the time. So this is these are the challenges related to the big data. That means how to capture the big data, how to store it, how to search, how to share, how to analyze, and how to visualize. Now, IBM describes this big data as V's, 3 V's. That means the big data has different dimensions. So they are also called V's, or also sometimes called the characteristics of the big data. So if these dimensions are present, then the data is called big data. Otherwise, it is called small data or a normal data. So what are these dimensions which makes the data as the big data? So the first one is called the volume. So volume is that these days these enterprises are ever growing data of all types, and therefore amassing terabytes, even petabytes of information. So you can see this Twitter is generating 12 terabytes each day, and this is being used to improve the product sentiment analysis. Now you can convert 350 billion annual meter reading to get a better to predict the power consumption. Now, the next dimension in the characteristics in the big data is called the velocity. Velocity means how fast you are generating, how fast the data is generated from the source. And so the time sensitive processes which are there to catch the fraud So that means the computation has to be done within a particular timeline. Otherwise, the data is the processing is of no value. So, for example, if somebody is taking the money from the ATM, so before he leaves or before he touches the cash, they will get the cash. All the processing, whether he is a fraudster or a normal person, account holder, has to be completed. So with that, big data analytics analysis has to be completed within a particular time. So this is why it is called the velocity. So that is the computation has to be done of this huge volume of data within a particular deadline, and this becomes the velocity. Another example of a velocity I can tell you is that Tatkal reservation. You know that Tatkal reservation during the festival time mostly fails. So that means that particular system is not able to complete the transaction, and they are saying that it's a link failure. So out of so many people who are now making the transactions, all the transactions are failed. Only few are successful to get the ticket. So this kind of things, which is called the velocity, is not carried out during the Tatkal reservation system. So that the failed transactions are more and the successful transactions are less. Yet all the money is being withdrawn from everyone's bank account. Another characteristics of a big data is called the variety. So variety means this is again I told you that variety means a different type of data. Is again the characteristics of a big data. So big data can deal with different type of variety, but all these varieties are divided into three different categories. First is called structured data, which you can fit into the table form. Relational database management system is an example of a structured data. Unstructured data is the data which is coming from the sensors, from the sensor data, from the text, that is from the social media, and then audio, and then video. That means all kind of different type of variety of data which is being collected is called unstructured data. Semi-structured data is the data which is coming out of the web logs and so on. So this kind of variety adds up different complexity. That how are you going to deal with semi-structured and unstructured data? Semi-structured data is so far often studied in the form of different formats of the data. Unstructured data is really challenging to deal with. So now we have seen the three V's, but there are many more V's. One more V is also there, which is making it as four V's. So the fourth V is very, very important, called value. So why you are doing all that volume, velocity, and variety is to gain values out of that. So value is going to be very, very important characteristics in the big data. So this you can see from this particular figure that that value is at the center. That means you have the first V, that is called volume, refers to the size, and the second V, which is called the velocity, which says that speed in which you have to do the computation or analytics. So the speed is the requirement. So size is speed, volume, velocity. The third important thing is called variety. That means the data sources are generating data of different type, whether it is unstructured or semi-structured. So it adds to the different variety. This complexity is being added with the help with this variety. Then velocity is another V which talks about the quality. So velocity means the losses or the imperfections or the noises which are there in the data, and you have to deal with this kind of data. That means when you are dealing with velocity, that means you have to be concerned about the quality of the data, which requires to make the decisions accurate. So another V is called the valence. That is giving you the connectivity. So valence is just like bonding. So connectedness inside the data is also one of the important characteristics of a data. And finally, the value is out of these particular characteristics. And value is most important because why you are doing the big data analytics is to gain the insight of it, and that is called the value. That means how to integrate these different data sources so that you can reduce the data complexity, you can increase data availability, and you can unify your data streams, and all together will increase and adds the value to your big data. So all these are different. These are also there. So it's not that only food V's are there, different other V's are there. Now let us see what are the different enabling technologies for big data. So as I told you that big data is used for the collection of data sets which are so large and complex that it is very difficult to process using traditional tools. This is one of the most important definition or aspects of the big data. And in the recent survey, it is says that 80% of the data created in the world are unstructured data. So you cannot say that only you have to work with the structured data. Then most information, most important insight which is there in the data will remain untapped. Therefore, this big data is there, that it is also going to deal with 80% of the data which is created in this world out of the unstructured data, and the big data will use that technology to exploit using these techniques, using these kind of data. So one challenge is how we can store such a big data and process this huge amount of volume. So later slides we are going to tell that. So Apache Hadoop is the technology, okay, which is used to solve these issues, which is as far as the computational part is concerned. So the top technology to analyze the big data is called Hadoop. Hadoop is Apache Hadoop is a free software, that is open source software, and can effectively store large amount of data in the clusters called Hadoop clusters. And this framework also runs in the parallel. Therefore, using parallel, it is able to process very fast. And the technology which is required to store the data is called Hadoop Distributed File System, HDFS. It's the storage system of the Hadoop which splits the data and distributes the data across many nodes in the cluster. So this is the complete overview of the Hadoop ecosystem. So in this Hadoop ecosystem, you can see this that you have the unstructured or semi-structured data which is being generated out of your social media data source, whereas you have the structured data which is also generated out of the different databases, and so enterprises data can generate this. All of them can be. So Sqoop will handle this. Sqoop is the tool of a Hadoop ecosystem which will handle with the structured data, and Hadoop is a tool which will take the data sources which are in the unstructured and semi-structured, and this will be stored in the storage which is called HDFS. And HDFS. So HDFS is the storage part of the Hadoop ecosystem. So if somebody asks you how are you going to store the data, what is the storage required? What is the storage technology to store the data? That is called HDFS, which stores the data in a distributed manner, distributed on the clusters. And then you have the tool which is called HBase is the database which is called NoSQL database. NoSQL databases are used to store this kind of the big data. Okay, so then you have various other processing. So the programming paradigm which is used for the big data computation or analytics is called the Hadoop framework. So Hadoop is the programming paradigm. Using that you can process the big data in this way. So there are many other things which is called, let us say, Spark, which is Spark is there. Spark is a compute engine for the big data these days, and it's much faster than your MapReduce. So Spark MLlib is the machine learning libraries which the Spark. So this becomes the Hadoop framework, Hadoop ecosystem. So Hadoop, you can see in the Hadoop SDFS is there to do this distributed storage. And then you have Yarn, and then you have a MapReduce. MapReduce is the computation which you can do, programming paradigm which you can use for programming with the big data, and big data analytics which you can perform requires the programming which is called MapReduce. These days, a new thing has come that instead of SDFS and MapReduce, which is very, very difficult in programming, Spark has simplified it. So Spark is another newer development that we will see in this particular slides. So I'm not going to go in detail of SDFS. So SDFS, I told you that it's a technology to store the data in a distributed fashion onto the cluster. So the cluster where the data is stored, they are called data nodes, and the one which indexes the data is called the name node, and this together becomes a SDFS architecture. And Yarn is yet another resource manager. So that means all the resources where the data node, where the space in the data node is available, all that thing is managed here using the Yarn. And programming model, which is for computation on this scenario, that is on this Hadoop cluster, is called MapReduce. So MapReduce is the map function which processes the key value pair to generate the intermediate set of key value pair, and reduce function will merge that intermediate values and generates this result. So this you can see over here in this slide that SDFS, that means these intermediate values which is stored, which is generated out of the map function, and map function is given the input from SDFS. So SDFS will read it, retrieve that stored data, apply the map function on it, and generates the key value pair. This key value pair will again go for shuffle and sort, and aggregates and aggregate values by the key, and then key and aggregated value is again then given the input to the reducer. So map and reducer, they are two programs. Together they will generate the final result. So another important thing is called NoSQL. So NoSQL, that is traditional structured query language, which is called RDBMS. It cannot be used to store only for the structured data, but not to handle the large amount of unstructured data. So for that you require NoSQL to handle unstructured data. So therefore, for a big data store, you require NoSQL databases. You store unstructured data with no particular schema. So we'll not go in details. You can see this NoSQL databases are also called column families, and you can store any type of data. And the typical examples to store this NoSQL or big data into the database is called Hive. And now we are going to see the Spark. This is a newer development in the big data. So Apache Spark is a big data analytics framework which was developed in 2012. And since I gained a lot of attraction. So today's time, this Apache Spark is very, very popular engine for framework for big data analytics. So Apache Spark is lightning fast cluster computing technology which is designed for fast computation. Apache Spark is lightning fast cluster computing designed for fast computation. Now another NoSQL databases which is very popular for storing the for databases for storing big data is called Cassandra, Apache Cassandra. So Apache Cassandra is highly scalable, distributed, high performance NoSQL databases. Cassandra is designed to handle huge amount of data. So this particular Cassandra it works on peer-to-peer fashion. So you can see that your data is organized in the form of that means the nodes are being logically organized in the form of the circuits, and this particular data is stored in that. So this we have already told. The next thing which is important technology for streaming analytics is called Spark Streaming. So Spark Streaming is an extension of the core Spark API that enables scalable high throughput fault tolerance stream processing of live data streams. So streaming data input from which comes from SDFS, Kafka, Flume, TCP, Socket, Kinesis, etc. Now Spark ML, that is machine learning functions, and GraphX graph processing are means compatible with the streaming data system. Hello. So is it visible?
Yes, sir.
Can you confirm?
Yes, sir. It is visible, sir.
Okay, thank you. Thank you for the confirmation. So I was telling about the Spark streaming. So you can see this Spark streaming is a compute engine. It takes the input from various sources, whether it is Kafka, Flume, SDFS, Kinesis, Twitter. So these inputs will be taken up and given to the Spark streaming. Spark streaming, what it does is the data which comes in the streams is divided in the form of the batches and gives to the Spark engine. Spark engine processes these batches of data, and the output will be stored in SDFS or databases, or will be displayed. Now there is another tool which we have seen in the Spark ML Lib. It's called Spark ML Lib. So it's a distributed machine learning which is done on top of Spark core. So MLlib is the Spark's scalable machine learning library, which is consisting of common machine learning algorithms and utilities. Common machine learning utilities, they are used to do classification problems, regression problems, clustering problems, collaborative filtering problems, and dimensionality reduction problems. Now, if you go to see the Spark MLlib different components, so I told you there are the algorithms to do this to solve these problems: classification, regression, clustering, collaborative filtering, and then you can construct a pipeline here in Spark MLlib. That means pipeline. That means these are the 4 different commands: constructing, evaluating, tuning, and persistent. And then you can do the featureization called extraction and transformation, and different utilities are also available. Now the next component which is there in the computation is called Spark GraphX. So Spark GraphX, as I told you that the graph and the network analytics can be done using Spark GraphX. So GraphX is a new component in Spark for the graphs and graph parallel computation. Now, this graph analytics can be done using GraphX. They can see this is the Spark, and just above the Spark, GraphX library is there. And the GraphX library has a lot of graph algorithms. For example, PageRank algorithm is implemented using the Pregel API on the GraphX. And connected component of a graph is also implemented using Pregel API and on the GraphX. Then triangle count and so on, LDA, all these are all part of the GraphX library. Now let us move again, discussing the simple form. Let us ask you that what is the difference between the data and the big data? So this slide I intentionally kept. Whatever we have discussed now, let us summarize it so that we can see some of the revisiting the same concepts, and then we have to go on to the next page in this lecture. So that means if you see what we have covered so far is that we have created the difference between the data and the data. So here we have seen the big data is not just the volume, but it is the volume with the fast data generation and computation called velocity, and also dealing with multiple data frames together called variety. All these characteristics are present, then it is called data. Otherwise, it is called big data. Otherwise, it is a data. So in data, all these characteristics are not present. Huge volume of data is not a big data. So it's a more volume, it's a velocity, it's a variety, all dimensions. All these are present, then only it is called the big data. Okay, so these kind of data which is generated by the humans and the machines TVs together. So that means these challenges we have discussed that more data means you require more money to spend, and RDBMS servers will become more costlier. But the trend is opposite. That means with the big data technology, more data will not require more money because the technology is stable. It uses something which is called the commodity hardware machines, which is not the costly computer systems for that purpose. And data is also coming faster. That is also a new challenge to deal with this kind of scenario. Then you require also the need to handle various kind of data structures. So as I told you that you have now not only the structured data, but you have semi-structured data, which is nothing but JSON data formats and XML formats and so on, and other such formats which are now supported. So this you can see that this kind of the cost, storage cost. Storage cost for RDBMS increases, but as far as the big data Hadoop framework is concerned, it's not increasing here in this way. So if you are dealing with the big data, then storage cost will not go much. This particular slide is going to be important to understand that how the storage is being performed in the big data. So old way means if it is only a data, then you can see this computation and data both are different, both are separated. So that means you have the computer, you have a separate storage for the storage, and there is a network which connects them. But in the big data in Hadoop, you know that the storage and the compute is together. Okay, so the compute node has to have that kind of storage, and that is used to store. So compute and store goes together in the Hadoop or in the big data scenario. So now the thing is, if you buy the sophisticated computer, so instead of that, what it does is that it uses the servers, which is called commodity and underlying servers. So that means these commodity servers, that means you can see your laptop is called a commodity machine. It has a processor, also it has the memory. If you can think of such commodity machines are in large number, so they will together will be a good amount of storage, and compute is also there on the same place. So compute and storage is together in Hadoop manner. So it's not a simple data. Simple data storage requires your compute is separate and your storage is separate. Keep on adding the storage is not the requirement of the Hadoop system or the storage for the big data. Now, if you talk about again the MapReduce. So if you see the MapReduce approach, here MapReduce is the programming model for big data, and you can see this particular programming is carried out on a big data, and you can see this big data is stored on different commodity machines in chunks, and the compute is also very close by. So the MapReduce function has to run in parallel over the distributed data. So data wherever it is distributed, the CPU or the processor is also there. So you have to send the commands or the processes to work on that particular CPU, which will now compute without moving the data. So data is so huge it cannot move at one place for computation. So initially the computation will move wherever the data is at the rest. So that becomes a map function. And the reduce function will perform the summary operation, that is to count, sum, and so on. So you can see this Hadoop versus unstructured data. So Hadoop has HDFS file system or just a file system, and you can store the data and you can compute the data. And so this we can skip at this moment. We have also seen the different type of analytics. This is the descriptive analytics I have told, and predictive analytics is again of two types of predictive analytics, supervised and unsupervised. So supervised analytics when we know the truth about something in the past. So these things we can skip, and now we are again back in HDFS. So if you don't want to discuss the HDFS, then we can skip, and we will now come to see some flavor of MapReduce programming. So MapReduce, I have already told that MapReduce uses the file system, which is called HDFS file system, and the servers called chunk servers. So they are also called data nodes, and there is a master node. And this particular MapReduce is used for large scale data processing. That means application or a program which uses thousands of CPUs. Okay, so for that kind of processing, which is called large data processing, that means 1,000, let us say hundreds and thousands of CPUs is required to execute one program. For that, this particular model that is called MapReduce programming model is to be used. Example is that you can see here that these terms are derived from. So let us see how the MapReduce does the computation. For example, here it is shown, welcome everyone, hello everyone, is the two sentences written in the file. So this is a typical, very small example, but the typical file will be the terabyte, and it will be in the petabyte and zettabyte size. If you want to do a word count, how it is done? So you can see in this example that after reading the file, it does the tokenization. That means for every token, it emits one value as one. For example, welcome one, and this is the map program. So welcome one, everyone one, hello one, everyone. So all the, and then the next part it does is that it processes the individual record and generates the intermediate that I told you about the map function. And then map function, what it does is after that intermediate keys has to be generated, intermediate keys values, and it will shuffle and sort in the sense that it collects all welcomes together with one, and all other keys which are similar kind of things, it will collect one. And then this is called intermediate values. And intermediate values together will be given here to the reducer. What reducer will do is now in the intermediate values using shuffle and sort, it collects all the words with everyone as one, and reducer will add them. So, for example, how many times the everyone is appearing is 2 times, you can see. So it will just add 1 plus 1 together. And hello is only appearing once, so it will go as it is. Welcome is also. So you can see this example that welcome 1, everyone 1, hello 1, and everyone 1 was given as the intermediate values out of map function. And reducer will take the everyone 1 and everyone together, and it will reduce it. That means it will add how many times this everyone is coming in the first task, the reducer number 1, and rest of the things. So here you can see this particular approach uses hash partitioning. That is, these key value pair which is emitted by the map function requires to be partitioned into the reducer, different reducer. So here in the example you have shown there are two reducer functions, reducer task 1, reducer task 2, and hash. If you apply on welcome and everyone and hello, and so automatically it will be hashed into reduce task 1 and remaining, that is welcome and hello in the reduce task 2. And then you apply this reduce function, and so it does this. So you can see this is the magic. Map reduce programming model is the magic which is being done on the big data for the programming into this. So we are skipping this. Let us take this example how the program for word count. This is the simplest program in the map reduce, how it looked like. So it looks like in this manner. Map will be having the key value, and for each word W in the value, the emit will so map will execute the emit function. It will generate the word and with value 1, whereas the reducer will reduce the key and the value. So it will count how many times that key is appearing and sum them. So that is called reducer function. So this is an example of a typical word count map reduce program. Okay. Now let us see some of the applications where this map reduce paradigm is used. It is used in the distributed graph. It is used to count the URLs, access frequency, reverse web link graph. And term vector per host. So these are inverted index, distributed sorting. So this particular map reduce paradigm is used at different places in the Google. Now we are going to see different big data storage technologies. So big data storage technologies, as I told you that Hadoop has the distributed file system, and distributed file system is suited for quickly ingesting the data. That means when a data source is generating the data, it will store them and use for the bulk processing. Now the thing is, if you want to use as a database, so for that big data storage technologies are there for using the NoSQL databases. So it will use the data models that are outside the relational world, NoSQL. So another development which has taken nowadays is called NewSQL. So NewSQL is a modern form of relational databases that aim for compatible scalability with NoSQL databases. That means it will be the functionality will be like SQL, but it is the NoSQL. So hence the name evolves. It's called NewSQL. Is a new technology which is being developed by a few companies, and maybe in future it will come up. So that means even the future, all the computations which a relational database is not doing, it can be performed on the big data also. So you can see RDBMS follows the acid properties, that is atomicity, consistency, isolation, and durability. But as far as NoSQL is concerned, NoSQL is different from RDBMS. So it is designed in a distributed data stores for a very large type of data. For example, Google and Facebook collects petabyte of data. So these type of data storing may not require the fixed schema, hence join and typically scale horizontally. So NoSQL stands for not only SQL, and it is not declared and there is no predefined schema and key value pairs of storage. It uses the column store. Here important thing is that in NoSQL, unlike SQL or RDBMS, you have consistency, but here in NoSQL, consistency is not guaranteed. So it is called eventual consistency. So it is not following the ACID properties. Hence, NoSQL and SQL. NoSQL is quite different than SQL that we have seen in the previous slides. So NoSQL can also handle unstructured and unpredictable data, whereas SQL cannot handle with unstructured and unpredictable data. Now, NoSQL follows a CAP theorem. CAP means consistency, atomicity, and partition. Out of three, only two can be chosen in NoSQL. So now new SQL which is coming up, which says that all three can be met. So if that is done, then there is no difference. There won't be any difference. It means those database technologies, that is SQL technology, can be used for big data also. Okay, so why NoSQL? Why you are using the NoSQL? So why? Because data is becoming easier to access and capture, and so that means you can directly take the data ingestion. That means take from the data sources, ingest and directly access it. Without formatting into the table and so on and so forth. So therefore, SQL becomes very popular in the big data scenario, such as personal user information, social graphs, location data, user data, and so on. Now, it required to process huge amount of data for which SQL databases were never designed. And so therefore, when to use NoSQL? When the amount of data is very big and lots of reads are there and very few writes are there. Means reads versus writes is there. That means a lot of writes, lot of reads is there, less writes are there. Once write and then remaining will be reads. For that, NoSQL can be used. It is economic. And it is a flexible schema and no transactions are needed here in NoSQL. ACID properties is not important, then only you can use NoSQL, and there is no join will be supported in NoSQL. So let us see the pros and cons of NoSQL. So the advantages are that it is highly scalable. And it supports distributed computing. It is having lower cost, and the disadvantage is that there is no standardization and limited query capabilities. Eventual consistency is not intuitive. HBase is again is another type of NoSQL things. So let us skip this, and there are different type of column-oriented database. These are called column-oriented databases, NoSQL databases. When I say column-oriented databases, it means here instead of storing the rows, we are storing the columns. Here in this case, so you can see this, the entire column is stored. Why the column is stored in the Cassandra SQLDB big table? Because in big data, it is not possible to fetch the entire rows for computation, but a column can be fetched. So a particular column, if it is fetched, then you can perform the analytics or you can search. a particular attribute, the values within that. So hence, it's a column-oriented databases. Now, another thing which is developed, which is called graph databases. So graph data structure, which is consist of finite set of ordered pairs called edge and arcs, and they are called nodes. And so graph databases represent the data in the form of the graph. In a relational database, you see that you represent the data in the form of a tables, rows, and columns. Join operations are there. Whereas graph model supports vertices and edge sets, and rows is representing the vertices, and column is representing the key value pairs, and joins are nothing but the edges. Okay, so this is the typical example of a graph databases. Now, let us skip it and now let us introduce about the Spark. So Spark is a big data analytics framework that was originally developed at Telconia in 2012, and it is used for the big data. Now, question is that why the MapReduce is not good enough, so that there is a need of a Spark. So it answers that this Spark simplifies the batch processing on large commodity clusters. So let us understand why there is a need of Spark, why the MapReduce is not popular these days for the new kind of applications. So you can see this is the structure of the MapReduce. That is, the map will read from the disk, perform the circle short intermediate, and these values are again read from disk and given to the reduce function, and then reduce again will write on the disk. So when we perform the MapReduce, one MapReduce round will have two read operations from the disk and two operations to the right. So it is expensive to save the disk for the intermediate results, but it is done to do this fault tolerance. But in the big data, fault is not the major issues. Hence, therefore, the MapReduce can be an expensive for applications such as iterative application and interactive application. What are these iterative and interactive applications? That means if you run the machine learning algorithms, so machine learning algorithms requires a lot of iterations. So in every iteration, if you write on if you save to the disk, and then again read from the disk, it will be a slower process. So it will slow down the entire system. Iterative and interactive applications. This is called iterative application. So for MapReduce can be more expensive. So if you want to run the machine learning algorithm, MapReduce is a very bad tool to support that. Therefore, these days, that AI and big data analytics requires how to gain the insight is through the machine learning, and from there, this MapReduce is not going to be really efficient. Therefore, it lacks efficient data sharing in the MapReduce. And alternative framework were evolved during the period earlier called bulk synchronous processing using Treggle and iterative MapReduce from Hadoop. But it was thought that these two things, which is called iterative and interactive, was not supported in the MapReduce. So it was required to develop a new model, and the new model is based on a data set which is called Resilient Distributed Data Set, RDDs, which is an immutable partition collection of the record, and can be cached for efficient reuse. And so if you see that the Spark is being made, so let us see here that from SDFS, if you read, from a disk, and this will become an RDDs. RDDs, that means whatever you read from the hard disk, SDFS, it will become the RDDs. And then you can apply the map function and reduce function And these particular map and reduce rounds, intermediate values will be cached. That means it will not be stored in disk. Hence, the computations are very fast. And then you have to perform on this the map and joint functions on it. Only issue is about the fault tolerance lineage. Fault recovery has to be done through the lineage. Lineage is nothing but using the log operations. You log off all the events which is happening, computation on the map and reduce is being logged. And this is called the lineage. So using lineage, whenever there is a fault, then only you have to go to the log and recreate all the RDDs. So that is the only case. So it is if there is no fault in between, there is no fault recovery required, then this Spark is much better. So you can see here that RDDs will keep track of the graph of transformation that build them their lineage to rebuild their lost data through the. So if let us say that some node fails, then you have to now use the lineage to rebuild data from the previous iterations and then rerun that particular command again. So therefore, accept the failures. If the failures are there, then the Spark is much faster than MapReduce. Now, using Spark, you can build these algorithms efficiently. That means all the iterative algorithms. One such example of iterative algorithm is about the partitioning. This is called the PageRank algorithm. And PageRank algorithm runs very fast using because you know that PageRank algorithm runs in the form of iterations. And iterations, you see these particular iterations requires a lot of storage. That means disk IOs, and disk IOs slows down. Whereas the Spark stores everything in the cache, and therefore Spark program, if you see this particular application, this particular program which is called the PageRank becomes very fast as compared to the this particular MapReduce. So therefore, these days where the machine learning and the iterative algorithms are the major one, therefore the Spark has replaced the MapReduce. Now, can see there's that given these RDDs, which is the resilient data sets of the Spark, you can have the stream processing, graph processing, and machine learning, all things together as integrated framework, unified framework and that is to be supported in the form of a Spark core. Okay, so Spark core supports RDDs, and on top of it, you can build. That means you can use the standard libraries are built, which is called Spark SQL, Spark Streaming, which is the real-time analytics, and GraphX and MLlib, that is machine learning. Let us see the Spark streaming analytics. So Spark streaming analytics, you can see that. Let us go to some examples. So let us see here. I told you that Spark streaming takes the input from different input sources. Let us say, and that is called data ingestion, Kafka, Flume, and so on. And Spark streaming divides the data into the small batches. They are called D streaming. And then the D streams are given to the Spark in the form of the batches for the computation. So all things we have explained. Let us see that if it is the input is coming from the Twitter, then you can see this the Twitter streaming API will do the ingestion into the Spark streaming system, and Spark streaming will divide into the very smaller in the batches of RDDs called D stream, tweet D streams. The tweet D streams will be given to the Spark core for computation, and the output using the function which is called a flat map. So you can see this particular transformation is quite easy and handy and efficient as far as Spark is concerned. So Spark provides a lot of APIs. You can see for Twitter and Java API also it is supporting. Now this streaming analytics, that is Spark, supports the window-based transformation. So window is a sliding window and sliding interval you have to define, and that means whatever stream data is coming, divided into the batches, and within the window you can apply this algorithm, and you can gain the insight. The example of a Spark streaming application is Netflix. Netflix uses Spark streaming for analytics here in this case. Now, another example of a Spark streaming is that, for example, if you are doing if you are doing analytics of an online sales, if you are doing sales product monitoring, then using Kafka, you can, if it is an online store, then it will read the input stores from the Kafka and apply this Spark streaming. And based on that, you can do this analytics. Whereas if it is something which is called a store, departmental store sales, for example, if it is a big bazaar, not the Amazon. So from there, you have a database. From database, you can read using Bloom, which I have told you earlier, and together, both of them, if they are representing the same product, then you can do this kind of analytics. That means you can join these two live streams. One is read out of the database using Flume, the other is read using the Kafka online streaming, and you can combine them. And so this is the example. For example, if you are having the input streams out of Uber and PayPal, Amazon, they are all online system, and they are generating continuous transactions, and they are being captured using Kafka. Whereas if you see Big Bazaar, Walmart, all that things, their sales record can be read from the database in the form of the streams, and both are given to the Spark streaming for doing this analytics. So this kind of details is there to perform this analytics, and most of the companies are now doing this kind of analytics. Let us see about the machine learning, which is there into the Spark system. So machine learning use cases, if you see, it can be applied in the healthcare, public sector, and so on. That means machine learning, everyone now knows that it can be applied in machine learning is, what is the machine learning model? If you see, is a mathematical formula with a number of parameters that need to be learned from. For example, mathematical formula is y is equal to mx plus c. So what is the value of n? What is the value of c? If you can learn out of the data, then it becomes a model. For example, by seeing so many inputs x and y, if you can derive what is the value of m and c, then it becomes a model. And this way of deriving these parameters learned out of the data is called a model to the data. And it is also called the model training. Now, the components of the machine learning is for classification. You have the algorithms which is supported in Spark MLU, is called logistic regression, naive Bayes, support vector machine, and forest. And for collaborative filtering, you have alternative least square regression, clustering, K-means, LDA, principal component analysis. Now, as far as the linear regression model training is concerned, as I told you that in a Spark, easily you can do. What you can do is, that means linear regression is, that it is used to predict the quantitative response y from the predictor value of x, variable x. Linear regression is made with an assumption that there is a linear relationship between x and y with one feature. Okay, so here you have to say, you have to use this linear regression and to fit in the model. So fit in the model means you can see this particular function, that if you say that you are applying the machine learning linear regression, and you have to say fit, and you have to give the data as the argument, then it will learn the model and it will give the values coefficient, that is in y is equal to mx plus c, m and c, these values coefficient and intercept both are being learned out of the data set which is given as called the data set. And ML machine learning in Spark, you know that it is supported above the data core, Spark core, and above Spark core you can see data frame APIs. Now you can see Spark ML different goals that practical machine learning is scalable and easy to use. It is simplify the development and deployment of scalable machine learning pipelines. So many companies are using it. Let us see what do you mean by this building a pipeline using the machine learning algorithm like classification, regression, probability predicting, and clustering. So here you can see this Spark pipeline starts with you have to load and clean the data and then apply the feature extraction, and then you have to perform the model training and model evaluation. So if you do in these steps, it is called a pipeline. So in this pipeline, this load and clean will remain the same. As well as feature extraction is called the transformer, and model training is called estimator, and model evaluator is called the evaluator. So load and then you have to do the feature extraction called transformer, and then you have to do model training called estimator, and then you have to evaluate the model. And these steps are called building up the pipeline. So all these things I have explained, but I'll skip it. So you can see this particular building a pipeline is quite simple in this part. So you can see in this example program that how it is easy to build a pipeline in Spark using the programming language called Scala. So you can apply, you have to use this function which is called tokenizer, and then you have to extract the features, and you have to also choose one of the machine learning algorithm that is here, called it as here as logistic regression, and then you have to create a pipeline. So the pipeline will have first use the tokenizer because the data comes and you perform this hashing and then it will apply the machine learning and it will fit the model. That means once you have built the pipeline and you have to give the data set or training data set, and it will now fit the model and it will generate the model. Now you can also set k-fold and all these things here in this particular pipeline. So this is the example. If you are, let us see that you are having you are specifying the machine learning algorithm which is called random forest classifier, and the number of trees, let us say is 100, and this is, let us call it as variable RF. RF is random forest. Now you have to build the pipeline. So stages are, first you have to apply the indexer, then parser, then hastia, then vector assembler, and after that you have to apply the machine learning. That is random forest. So in this particular pipeline, once you build pipeline and you call it as pipe, and then you have to apply a function which is called a fit. And on a fit, you have to, as an argument, you have to give the trained data, and it will give you the model. And this particular model, now you have to apply the transform function. And using transform function, you have to give the test data, and then you can get the result and you can do this analysis. Now we will skip it, this parameter server. Now if you want, we can discuss the GraphX APIs. So GraphX is graph analytics. So graph analytics is very widely used these days, whether it is the web graph, web pages, Wikipedia, all things are being used in the recommendation engine also. This graph X is used So you can see this particular thing that graph and table, they are interchangeable. So you take this raw Wikipedia, which is in the form of the XML, and you can store in a table which is called the link table, which is the title and what is the link in the Wikipedia. You can also store this Wikipedia into the editor table, where you have entered into the editor and title of that. Now, after that, from link table you can construct the hyperlinks, and from the hyperlinks is a graph. So from the table you can construct a graph which is called hyperlinks, and from the hyperlinks, if you apply the PageRank algorithm, it will give you top 20 pages, which is stored in this particular table title and PageRank of that. From that PageRank algorithm, you can also build another table which is called top communities. So communities and their PageRank. Whereas on the downside, once you have an editor table, then you can construct an editor graph, and from the editor graph you can apply the community detection algorithm. And from community detection, you can identify the communities to be entered into the table, and PageRank will come from the PageRank. And user community also you can build. So therefore, you can see this one such table can be converted into a graph. Applying the algorithm, and again you can convert into the table. So table and the graphs both are interchangeably convertible. Now, if you want to do the analytics, the graph analytics, on the airline reservation, on the airline operation system. So you can see there are different airports, LAX and SDS, they become, and the flights which connects them. This entire operation, that is airlines operations, can be represented in the form of the graphs. So these particular graphs can be then applied on GraphX for different analytics. That is, we are skipping it, and this is all to be done in the big data analytics. So this particular GraphX, I think, is also an important use case and application. Therefore, we have in the end discussed about different Spark applications, specifically the Twitter spam classification. Then we have also seen different machine learning algorithms which are there in Spark, and also algorithms which can be used for different recommendation engines. So with this, let me stop this lecture and let me take some questions which is more interactive to discuss on this point. So questions, please. If you can give a question on the chat box, then I can be able to address them.
Thank you, sir, for your nice delivery, sir, related to this big data issue. Our participants are requested, if you have any question or any query, please put it in the chat box so that
Please type your question in the chat box, so one by one I will take up.
पहले एक आंसर तो करें, पूछ लेते हैं. तो
ये तो उन्होंने बताया था इसीलिए मैंने इसको पूछ लिया। इन्होंने ये चीज़ जो मैंने क्वेश्चन पूछा इसका जवाब ये इनकी स्लाइड में लिखा था, इसीलिए मैंने डाल दिया।
Sir, there is one question from one of the participants.
Hello.
Yes, sir.
Hello.
Hello.
Somebody is asking a question, what is the size of any data to be said as big data? Okay. So, this is Praveen Tripathi asking about this question. So Praveen ji, let me tell you that, your question is that first you have understood that only size is not important to be a big data. Okay, so all these are required. For example, along with the volume, you also have the velocity, variety, all that things. So the size starts from petabytes, zettabyte, which you cannot store, which cannot be stored in the traditional means of storage. So that becomes the big data. So petabyte, zettabyte,
Okay, sir. Thank you.
and another question is from Shweta Vikram. How machine learning used in big data? Okay, so I told you that big data is stored in the form of cluster, whether it is Hadoop cluster or Spark cluster. So once the data is stored in the cluster, or if it is a streaming data, then you can apply the machine learning algorithm on this big data technology, whether it is Hadoop or it is Spark. So in Spark, this machine learning algorithms are implemented in the form of Spark MLlib, which I have shown you in the slide. If you say I can upload again. So can you see the slide or I have to upload again? I think you can see the slide.
Yes,
I can
slide.
change the slide.
Slide is visible, sir.
Slide is visible. I will go to that point.
Yes, sir.
Here you can see. Here you can see it's a machine MLlib. Can you see this MLlib?
Yes. Yes, sir. It is good.
So MLlib is a library which is there in the Spark core. So the Spark used to implement the machine learning using this library called MLlib. Now the data and MLlib support these programming. Through that you can call these machine learning library. For example, machine learning which I told you, which is being supported in MLlib is for regression. So all these classification, regression, recommendation, and so on. So these kind of clustering. So these algorithms are implemented. Different machine learning algorithms are implemented in MLlib. Using Scala, Java, Python, and R, you can use this MLlib. So if you are using these languages and calling these particular program, you will not feel as if you are working in a big data. The APIs will make you feel that yes, it is well-known K-means algorithm or it is logistic regression algorithm, and so on. You can apply. Now you can see below Spark core, different data sources are there. So that means the data, different data sources you can tap and apply the machine learning. This is most important part in big data. So data sources means you can read from the database, from the database which I told you, the Cassandra is written over here and HBase is written. So they store the big data into it. So you can read from there that particular key value store and apply the machine learning on it and you can gain the outcome. So this is how the machine learning is implemented uh, in the for the big data. So any other questions? Let us see. After Shweta,
No, sir.
I don't think any other questions. So let us thank everyone and thank organizers also
Thank you,
for
sir.
patiently listening to my talk. Thank you so much.
Thank you so much, sir. Thank you so much for your nice delivery, sir, related to this big data. I again thankful to you as your session is very much fruitful and research oriented session you have given. Thank you all, sir. Thank you, sir.
Thank you. Bye.
Okay, sir. Dear participants, please fill the attendance using the given link as given in the chat box, and also requested to please fill the feedback form. The link is given. It is mandatory to get your e-certificate also. Please fill the attendance and feedback form both. And now this is the end of today's session, as we completed 6 sessions of FDP on data management. Yet still lot of fruitful and knowledgeable discussion yet to come. All are requested to join as per the schedule already shared with you, and we expect you will surely get all the benefit from the all the session to be held from tomorrow onwards. So we are just concluding today's session, and we will meet again on next morning on 10 o'clock. Thank you all. Thank you to join this session. चलने दे रहे 5 बजे तक। ऑफ कर दिया इसको। ठीक। हमने ग्रुप में भी डाल दिया। फीडबैक का वो तुम डाल दिया। What happened today? Come and said. What happened today?
डीएससी वाले सर सीएस में एक्स्ट्रा पढ़ाए होंगे कुछ, आज कंबाइन हो गया, हमारे में वो टॉपिक फिर से वो पढ़ा रहे थे, हमारे में नहीं पढ़ाया था, तो एक्सप्लेन कर रहे थे, तो उज्ज्वल हंसे जा रहे थे लगातार कंटिन्यूअसली हंसे जा रहे थे। हम लोगों ने बोला उज्ज्वल से भाई शांत हो जाओ, सर हम आपको एक्सप्लेन कर रहे हैं, समझ लेने तो हम लोग को, तुम समझ चुके हो तो, लेकिन वो बोले ही जा रहे बोले ही जा रहे बोले ही जा रहे। ऐसे ही जब 2-3 बार बोला हम लोगों ने तो उज्ज्वल भी गुस्सा आ गए, तुमको ही क्यों बोल रहे हो, सब बातें कर रहे हो, तुम सीआर हो, तुमसे ही तो कहेंगे हम लोग कि सीएस को शांत कराओ, सुनी नहीं रहे, उसी में खड़े हुए लड़ाई करेंगे। दर्शक फर्स्ट टाइम हम लोगों ने बोला उज्ज्वल खड़े हुए लड़ाई करेंगे, ये क्लास में सर के सामने डीएससी वाले सर खड़े हुए थे। सर हम लोगों ने फर्स्ट टाइम बोला उसको, तो कह रहे तुम अपना देखो, सीधा बोल दिया। वो कह रहा हमको ही क्यों बोल रहे हो, तुम सीआर हो, हम लोग तो तुम ही तो बोलेंगे, जब सीआर ही बात कर रहा है तो भाई बाकी लोग तो करेंगे क्लास को रिप्रेजेंट तुम ही कर रहे हो, वही बातें कर रहा है। इस सर रोहित सर से पूछ लीजिएगा, हम लोग की बात नहीं, तो रोहित सर सामने खड़े हुए थे स्टेज पे, उनके सामने की बात बता रहे। हम लोगों ने सर से भी कहा एक 2 बार, जैसे सीएस वालों से बहुत शोर आ रहा है, उनको शांत करा लीजिए, हम लोग को समझने में दिक्कत हो रही है। ये बात हम लोगों ने सर से पहले बोली थी, उसके बाद उज्ज्वल से बोला उन्होंने डायरेक्टली। जी ये सर गाली गलौज सर के सामने वही बात है, सर आप सीआर खड़े हो पहले गाली गलौज कर रहे हैं, तो उज्ज्वल ने भी दी थी, और उसके बाद जब उज्ज्वल और अर्जुन का शांत हो गया तो पीछे भी 2 लोग भिड़ गए थे, ये राइट के अलग आपस में क्लास में गाली
चारों का नाम लिख करके मुझे आप दे दीजिए, मैं कल देना दोनों चारों को भेज दीजिए। मैं उज्ज्वल के साथ में बुला लूँगा, उज्ज्वल को तो बुला ही लूँगा, लेकिन चारों का नाम लिख के दे दीजिए, जिससे कम से कम एक बार को लोगों को मैसेज तो रहे सबको इसी के थ्रू कि जो ये चीज़ें रिपीट नहीं होनी चाहिए।
क्लास में हुआ
अरे
है
मच
ये
जब
वही
क्लास
बात
हो
है।
रही है तो उसको तो आप इस तरीके से नहीं कर सकते ना कि मतलब कोई भी अपने मन से कुछ भी करने लगे भी है।
यस सर।
आप मुझे नाम लेकर के दे दीजिए, जैसे एक बार को मैं बुला के बोल दूंगा।
मतलब उज्जवल से तो सबने ही कहा था, उज्जवल से किसी एक पर्सन बच्चे ने नहीं कहा था, उज्जवल से तो कई लोगों ने बोला कि भाई शांत हो जाओ शांत हो जाओ, लेकिन उज्जवल सुन ही नहीं रहे थे। और बाकी जो पीछे हुई थी उसमें कुछ नहीं थे।
मुझे ठीक है, तो नाम लेके देना, नाम लेके देना, कल एक बार बात कर लेंगे, ठीक है?
उसे कल मॉर्निंग में आपको नाम दे देंगे।
नहीं अभी दे के जाओ,
अभी दे दो।
कौन सा लग रहा तुम्हें?
नहीं सर,
सर इसको बंद कर देना, 6 बनाए बाकी
जब
ऊपर।
बात हाँ इसको बंद करके मतलब इन्हें
पूरे क्लास में वही चिल्ला दिए।
यार ऐसा तो बिल्कुल
जब यार ऐसे करेगा तो क्लास में क्या ही
हमें तो
होगा।
कुछ उल्टा बता के किया, क्या ये वाले कर रहे थे।
आप रोहित, अब बच्चे तो अपने आप सारी बताएंगे।
हाँ।
आप रोहित सर से एक बार कंफर्म कर लीजिएगा ये बात की क्या हुआ था।
हाँ कम से कम सीआर से तो एक्सपेक्टेड
ये
ऐसा
तो
बिल्कुल
यार
नहीं होता है।
expected है।
हाँ।
वही अमन का पूरा ग्रुप था वो। ग्रुप में
हाँ चलो वो बाकी तो ये सब बताएंगे ना,
उन्हीं के साथ कोई बैठा था हम लोग को नहीं ध्यान है
बाकी
इतना।
तो वो खुद बताएंगे।
पहले हम लोगों ने बोला है कि शांत करा लो, फिर वो सीधा इस तरह कह रहा है कि तुम वो अपना देखो।
और वो ये मतलब उसने मेन ये कहा कि तुम लोग हमको ही क्यों बोल रहे हो सीएस में।
यार
बाकी
सीआर
बच्चों
को ही
से-
तो बोलोगे,
अब
सही
बाकी
बात है।
बच्चे जब बोल रहे हैं सीएस में तुमने उनको नहीं बोल रहे पर्सनली हमको
फिर
कह
सर
रहे
हम लोग
हो।
अपना देखने लगे, तब तक आशिक लोग बोला कि सर सर से बोला कि सर सीएस के सीआर खुद ही हंस रहे हैं तब से।
अब जब सर से यही बोलेगा ना सीआर खुद ही बोल रहा है तो बाकी बच्चे क्या ही करेंगे।
उतने को बड़ा करके कह रहे तो हमको भी बोल रहे हो।
पूरा दे दो, इतना बड़ा फंड नहीं दे दो, कोई दिक्कत
पूरा पेज दे दो।
नहीं बस मतलब एकदम ऐसा, हाँ ऐसे ही दे दो, चलो छोटे।
फुल पेज में लिख देते ना
अरे कोई बात नहीं।
इसमें 2 सीएस के हैं 3 आईटी के हैं।
अच्छा ठीक, उज्जवल का भी नाम लिख देना है।
उज्जवल का टॉप पे है।
हाँ हाँ
पहले ही नाम उज्जवल का है सर। 2 पेज आगे तो शीट चाहिए थी फिल करने के लिए, खत्म हो गई है।
खत्म हो गई। सुबह ले लेना,
ओके
सुबह आके ले लेना।
ठीक है, गुड इवनिंग।
ओके ओके।
थैंक यू।
you.